Morning and happy Friday. Happy Friday, everyone. Good morning. Just gonna finish setting up. We're almost there. So that's Chrome. All the stuff over there. All right, Capitan's awake. Good, good. So, first order of business. 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 Busyness. I'm gonna run Godot. I did a little research and was able to switch this over to using GLES2. You can see that up there, which surprisingly drops my CPU usage a lot. That's a good thing. So we shouldn't have render lag, stuff like that. So there we go. Yep, things seem to be all right. Oh, there goes a little whoosh. These are good. Same. So far, so good. All right. So yeah, this is GLES 2. One of the big differences between GLES 3 and doing an effect like this with a glow is that HDR doesn't have as many bits. So if you try to go over 1, it doesn't work. You can't go over 1 here. So if we said, this is 2, that doesn't actually cause it to glow more. So, well, I guess it does just a little bit, but it doesn't get brighter because we've filled out all 8 bits there. GLES 3 can use 16 bits there. So, yeah, it looks like occasionally we're going to get a little bit of rendering lag, misframes there, but that is much, much better compared to what we were doing yesterday. So, expect a smoother stream. Give that a little run. So we're going to change this. I mean, it's really, really nice, but I don't want it like this. I want it to go around. Whoosh. So we need to be able to calculate the UV for this in a long strip. So that's the first thing we're going to change. Good morning, Xenocron. How are you today? So remember, we're going to try to calculate the UV so we can just get this continuously moving around. It's pretty, isn't it? I think it's pretty. Want to see the fade off here? Yeah, wow. What? Why did this happen? What's going on there? That's so strange. Is that's something completely different? That's this program over here. This should be able to just consume bytes all the time. And that's on localhost. Why couldn't it send packets to that? It's okay now, but hmm, we'll have to keep an eye on that. All right, back to it. Let's adjust this. Great TVs. This is left to right TVs. And how do we create the path UVs? Let's bring up a sprite. I know it. I think I know what the drop frames are. That might help. We'll see. Here goes my OBS settings. Some other setting. All right, so we have rounded rectangles. So we've got the inner one. Imagine these have rounded corners on them. We have the outer one. Okay. Now we're going to pick some arbitrary point, maybe like here, something like that. All right, so if we picked here, we would have to go around the track because this is going to be tessellated. So this is going to have all sorts of little tessellation bits, right? It's triangles. It's made of triangles. Who knows how it's actually going to be tessellated. I'm adding more in the corners just because that one's a little long. That's fine. All right. So our arbitrary point isn't actually determined by us. It's determined by whatever the beginning of this is. Okay. And that's fine. We will just have to figure out some sort of algorithm that we can use to make this scan these like a clock dial, right? Whatever the hand is on, right? Wherever we currently are. So it might start here, it might start over there, it could be anywhere, right? So let's say we're starting right there, and or I guess that wouldn't be the case. It would be some vector, so it'd be like over here. So we might be starting over there. And from 0, we could say, okay, what is your angle from here? That's fine. And this would say, based on that, your UV, this is 0, this is 1. We'd go around the circle. We'd say, okay, you right there, you're like if this is 0.5, over here on the right, this would be less than half of that, so maybe like a 0.1. Oops, like a 0.1, right? So we would go around the circle like this. And we would then see how this works in the corners, right? Because we might actually need 2 points or 4 points. We'll see. Because of the way that the corners are set up, if we detect that we are in a corner for those vertices, well, depending on the tessellation and how this looks, we'll spend more effort on it. Because if it looks good, we'll stop with a simple one. If it doesn't look good, then we'll spend a little bit more time to make it look good. All right. So we need to know what the center of this place is. So knowing the width and height is still useful. These are the center points. Center X, center Y, divided by 2 on this, 2.0. So that should be the center. Vector 3. If we convert this to a vector 2, well, if we convert these other vectors to a vector 2, we might be able to use some functions on them that would tell us the angle. XY. All right. Let vert. Can those vector 3's be converted directly? This is interesting. Occasionally we do still get errors with the packet dropping. And that is so strange. Because what would cause that? What would cause this packet dropping? This packet loss? I mean, bit rate's good. Hmm. That's gonna bug me. That's gonna bug me. Oh, did I flip the webcam? I don't think so. This is still that side. Why do you ask? I stood up. So today I'm standing. Yeah. Oh, because here. Oh, you're right. It's quite weird seeing you stare at the chat. Because this is me staring at the chat over this one is over there. Oh, you know what? I I did do that. There. Now it's over there. We got other stuff over there. Thank you for catching that. Let's see. Is this one the same way? Yeah. Okay. Chat. not chat. I wonder what's causing this. It's not like the buffer is going to get full. Oh, looks like we had a couple of spots in there. This weekend I'm actually mounting that dish. I got the mounting kit. It's on the shelf here somewhere. I get some piping, some brackets. That's going up on a building. So actually the goats yesterday knocked it over. I was in the middle of a meeting, a work meeting, and suddenly no internet. Then I check, it says motors are stuck. It's like, uh-oh, kids playing with that? Turns out it was the goat kids that were playing with it. All right, for vert in verts. Vet vert dot y. All right, and what do we have in a vert? No, it's a vector 2. Angle 2. And we can give it another one. It's between negative pi and pi. That works. Is there anything else? Splat? Huh. What is splat? Oh, constructor setting all the components to the same value. That is a weird name for a constructor. Is this a common name? Splat? So we could probably even do this. X, Y, underscore. Does that work? If we can go into that. Oh, hmm. All right. Angle from x-axis. That that might be, that's not what we want. Okay. Actually, let's do it the other way again. All right, then we have angle. Now we have to return a vector 2 for what this is. Now, for the y's on these, for the UVs, I'm just going to leave it as like 1 or something. Like it's always going to be the same value, maybe 0. Vector 2, new. Oh, we have to adjust the angle. Let's call it x. And 0 to 0. And this goes from negative pi to pi. So let's add pi and divide by tau. Or just, so it's f32 colon pi. Is there no, wait, where's pi? Oh, it's off of consts. That, hmm. We do it divided by equals. Ambiguous associated type. Looking for the standard type. See, look at these. Very, very helpful errors. Oh, that's an angle. That explains things. Um, so if that's an, what is an angle? I think it's going to be this one. Radians F32. Okay, so we can just ask for radians. That'll return that to us. Now we get an F32 back. That's interesting. What does this return? A vector 2D returns. So the angle 2 returns an angle of t. I think this is our angle. Oh, it's a field, not a function. All right, so let's see how that works. Now I have a 0 to 1 there. It's doing a build. All right, Godot in your OpenGLES2ness. Oh, we still got our glow. Oh, that was interesting. Okay, let's adjust our shader. That is weird. I want to see this a little tighter. We should break this down. Is that correct? 1, 2, 1, 2. Okay, let's call it S. That'll fit on one screen. Yes. All right. Actually, that's fine. It's divided, times 2 pi here. Trying to get multiple on the screen at a time. So I wanted to just go around. Right. Oh. Oh, that's great. Because we had the bloom filter, now these things also have have a glow, or the glow filter. That's funny. All right, but you can see. So if we slow it down, to dot zero, yes, we know it's a float. You can see that it's actually coming from. It's like it's like the point is out here, and this is a lighthouse casting a beam across it. So our UVs are not being calculated correctly. So our center point compared to these is wrong. Huh. All right. And it looks like it's coming from up here. We go slower. Is that faster? That's faster. Wait for it. There it goes. Yeah. Okay. So I think our shader is correct. It's just that our UVs are not being calculated right. That's a neat effect. All right. And thank you for the follow. Associated function is never used. Yes, that's fine. Was it dead code? All right. Let's just see where this ends up. It's either the center's off or these verts are not where I think they are. These verts are not where you think they are. So I was thinking about the curve problem. All right. So it's a number of vertices. Let's just scroll back up. All right. So we have a vert at 18,0, and our center is at 9,4. It's like 0, 0. Our center is at 9,4. Oh, it's because the sign is flipped for the Godot verts and not the center. Aha. Well, that's only part of the problem. Why would it be off that way? What? Yeah, X17, okay. 050, 17,0. What else do we have? Little sample here. I'm looking for a large value for Y. I'm not seeing it. These Y values all seem to be pretty tame. Yeah, something's off with those Y values. Let's take one more thing. I think the center, we got that better now. But I want to see more of the vertices. The verts Y. And Z should always be 0, or rather it should be something that we don't care about. So, what happened to the frog scar when it broke down? It was towed away. Da-dunch. Where's our laugh track button? I'm so doing the laugh track button. I know, first the camera, now the laugh track. Yeah, it's still doing the same thing. These are not large values. Why aren't these larger values? -4? Is this? What's the height of this? I know, that might actually be a good value. -0.4. Because its location, I don't know, what's its size? Okay, let's close that. So we have zero point 0.1 for all these. And the outer box, okay, maybe the problem still is with that, with the origin. Look at that. Look at it just casting from actual origin. You guys got any weekend plans? I'm gonna mount Starlink. All right, did that finish? No, very soon. What? Oh, awesome. Sorry, one of the packages is gonna be here earlier than I thought. Oh, nice, nice, nice. Storm King's Thunder. That's what it's called. That and the mic. All right, so let's kill that. Run it again. Oh, that looks neat. All right, center. Negative 1.1. That looks like it's about the center of these values. -5 to -1 and back. Yeah, that looks fine. Okay, so the problem must be somewhere else. All right, so where would this be? Because if these are correct, then it must be here. What is our angle? Right? We'll print out two angles. How's OBS doing? Yeah, OBS is doing all right now. I don't know why it was having trouble earlier. Maybe it was Starlink, maybe it was something else. That and our build is getting slower and slower. It's taking what, 20 seconds? 20 to 30? Oh, 50 last time. Wow. All right. 1 minute 7. That's unreasonable. All right. Let's look at the data. All right, so here we have center. Center is 9, negative 1.1. The y here is negative 1. The angle, we kind of need the x here, don't we? We do. Let's take a peek at these first. So yeah, depending on the x, where's this y? What's our range on these values? We have 0.3, or let's say 0.3, 0.5, 2, 4, 0.3. Yeah, we only ever get to 0.52. I didn't see a larger one than like 0.52. And that coincides with this. It's just silly. Where's this gone wrong? It feels like it's still using 0, 0 for some reason. We know it's not using center. All right, there must be something subtle that I'm missing. Quick Godot. Yeah, see, it's still doing the same thing. It's like broadcasting from the other side, or casting that ray from somewhere else. We'll leave that one. It's going to be a lot of data. We could simplify the amount. If we do x here and then y, because otherwise it's going to do the structure format. Or we could put it condense a little more. Now we're down to 20 seconds. Like, was it the blocking? Maybe. All right, where's center? Do we skip center? No. Scroll up, up, up. Here. Here's center. 9. And we have our vertice, which is at x of 0.5. Why is our x at 0.5? Is that like the top left corner? X, Y. Negative 1.8. Okay, so this It says to the left and below. I kind of want the angle before we calculate it. Feels like this has gone wrong here. Let's put that there. So 17, that's going to be far to the right, 1.8. This is like in the bottom right corner. And the angle is 0.5. Now let's find one that is in the top left corner. So kind of like this, but higher up. The Y is still high. Hey, thank you for the follow. So let's drop these. So that's 0.5. I'm looking at the Y values now. Okay, let's find top left corner. It feels like this one's the top left corner. That's still the wrong value. All right, run it again. So now we got the angle from negative pi to pi getting printed out. That doesn't look like from negative pi to pi. All right, let's create a test here. Okay, close that. Goodbye, Godot. Let's just create some test. Test module, test. What is it? It's a vertice. Vector 2, new. It's going to be at some simple value, 5.0, 5.0. Let's say this is our center. All right, now let's have top left, 0, 0, 0, 0. All right, what is our angle going to be to that? Let's also have a top right. This will just be 10. Bottom right, and this is 10, 10. Okay. Technically, no, it's not, is it? Let's do this with the sign flip as well. All right. Center dot angle to top left. All right. I'm going to say that I'm expecting 0. That's not the right value. Thoughts on 4V cores? 8 gigs of RAM and 200 gigs of SSD. That's That seems like a good deal. I mean, it depends on what the V chorus mean, right? Like there isn't like V chorus aren't all the same. It's like a Raspberry Pi. I mean, maybe they're overselling. Oh, float angle. Yes, yes, yes. Um, no, no, by all means, distract me away. I'm doing math on a Friday morning. Come on, you can do it. That looks correct. No, it doesn't. Wait, wait. That's in radians. That's not in pi. Sorry, that's from 0 to 1. Oh, okay. I see the problem now. Yes, I didn't convert to radians. So the other code here was it UVs, path UVs. Radians here actually takes it. It's a 0, then you get to 1, and then you come back around to 2. Was it? Radians. So you have pi on the right side. So it's 1 pi? They have 2 pi? If that's the case, just leave that there. We'll return a vector 2, new. Angle divided by 2 and 0. 0.0. Oh, semicolon. Should have seen it. Yeah, yeah. It doesn't need to be immutable. Let's just test it though. Rust errors are the best. No, it's still doing it. It's as if our 0, 0 point is not correct. So I'm gonna test these. 2, 3, 4. Top right. Oh, that was 0 point. We did the top right. I thought we did the top left before. Okay, top right, top left, bottom left, and I mean this should be basically pi divided by 2. No, pi divided by 4. Standard F32 pi divided by 4.0. And this is going to be the same thing, but it's divided by 4 times 3. Hefe, how you doing, man? Trying to improve our little glowing border box here. I actually want it to, you'll see it here in just a moment. Um, See that little swipe through there? I want it to go around it. You feel a little a little punchy this morning, huh, Zenocron? But you can see that that this swipe is actually coming from the wrong center point. It looks like it's coming from like up here, like its origin point, and not from the point that we want it to come from, which would be in the middle. So we're creating a shader, trying to get that to work. I mean, it's looking pretty good so far. Do I do I plan to do other Rust stuff besides Rust and Godot? I do actually, and I've done a bunch of Rust stuff besides Rust and Godot. Just plain Rust server stuff, right? Because we were building on a MMO backend. Yeah, we did streaming related tools. That's right. A bunch of that stuff is open source. Some of it's not, because it's easier to give than take away. Const. All right, let's just see how close we got here. Yes, I do. Yes, and we've got a little command for that. Where is it? No, no. They end up over there. Expected expression. All right, let's just do 0.0. I just want to see what the value is. And you know what? If I just want to see what the value is, we should just debug a dbg. Hey, that way we can see all 4 of them. Bottom left. No, I found it in the scope. Uh-oh. 590. 590. Oh, yeah, we didn't do bottom left. Fine. You win this time, Clippy. Oh, you're welcome. And how are you doing with Rust? Are you programming in Rust? Do you have Rust questions? Oh, I got a message. Tea or coffee? This morning, before the stream is tea, after the stream is coffee. Oh, I need to call the dog over. Be right back. Dog's bugging the goat milking. Good morning. How you doing, Tag? Ah, we didn't get our cargo cargo test. The Rustations team on Twitch is a pretty good place to start to look for people doing Rust. Yes, it is. Yeah, there's a lot of people. Bear Doodah, Togglebit. Um, oh goodness, forget blanking on the names. Um, I can see his face. I can see what's it? Where is he? What's his name? Um, Brooke. Yeah, Brooke streams. Peyton rules occasionally. John who? I don't think Musean is in that team. Because to be part of a team, you have to be, what is it, not an affiliate, but I don't know. You just have to make it a little next level. He just never clicked the button, which is fine. I say he. I mean they. We don't know much about Musean. Okay, so A, what? 0.75, NAN, and 0. Why is this one NA not a number? Really? Top right. Yeah, you have to be affiliate but not partnered. Yeah. But Musean also does. Musean does a bunch of stuff. So, okay, looking through this first one, we got 0.78. I think so. The problem is just me not understanding their API. So I have center, angle 2, that. I thought this would let me basically define an arbitrary origin point, right? This is when we say center, angle to top right, and we get the radians there. That gives us 0.78. But the second one gives us not a number. So the top left, angle to 0, 0, which is just another point in space. As if we're at negative 5, 5, and we say we want the angle of this, I do expect that to be an angle. What? How in the world? And then this one here at the bottom is 0, and this is bottom right. Oh, should we be using a different type? These are vectors, right? No, points. Let's see, we want which point? This is going to be from Leon math point. It's going to be one of these points, which is an alias to Euclid, fine. And Euclid points, they have an x and y, distance to, if we subtract, add, sub another point, that gives us a point, doesn't it? Yeah. How do we get the angle between 2 points? So we want to look in Euclid, got a vector 2D, rotation 2D. I see what we have to do now. We have to subtract the vector from the other vector. The angle between the 2 points is the dot product of the normalized vectors. Dot product. So this gives the cosine? I see. Then I'd also have to basically convert them to points. Do we have... Ah, good. Just a sec. Wife is texting. All right. So, different question. Because I don't see that on there. Vector 2D. Euclid's structure. I see. So we basically normalize the vectors, take the dot product, returns a t, which is going to be the same type. And then we can get the, what is it, angle from x-axis on that? All right, this one here. Thank you for that, Taug. Should return a double flow. Here, let's normalize this. All right, now center. Now, how does that work if we normalize this here? Because this vector is actually going to be kind of down and to the right. And I want, actually, okay, that's actually going to give us the wrong thing than what I'm thinking. So here, let's go over here somewhere. So here we have origin, right? We have some sort of graph, some lines. There's origin up over there. And in Godot space, we usually draw a negative in the Y space here for the UI stuff. So this would be negative, whatever. Then we'd have positive up here, right? Typical graph, right? And we end up with our rectangle down here with our points being around this, right? Because we have this cool glowing thing. And what I want is from this point here, what is the angle of, let's say, this point here? So in this case, if we just took the vector and normalized it, now because all of these vectors are actually, they're vectors from here, right? Which is why we see the ray casting the way it is. But we don't want it that way. So we have to subtract these outer vectors from this one. And correct me if I'm doing this wrong, please. Please do this. So we need to subtract the center from this. So before we normalize it, vert minus center should give us another vert. And we'll have the xy in there. And then we can simply get vert dot center, no, angle from x. Normalize, no, into the dot product. Yeah, I don't really need the cosine between them. But like from x would be fine. Angle from x-axis, I think that'll give us an angle. And this angle is what? Where 0 is plus, okay. Because this can actually be arbitrary for our purposes here. All right, that was a good test there. Actually, let's pour some tea. This this morning we have it's an apple spice. Oh, hold on. What happened there? Oh, radians. Just change that to radians. All right, now we'll pour the tea. Oh, it smells good. Oh yeah, and that does not need to be mutable. That's fine. We'll fix that up after testing it. Okay, it built. Oh, it didn't build. My mistake. What did the can crusher? Why did the can crusher quit his job? Because it was soda pressing. Get it? Soda pressing. Yeah, well. Oh, look at that. It doesn't spend long in here on the sides. I wonder why. Like what's going on over there? Oops. Perspective. Front. There's a bit that it doesn't do here. Oh, this region here is actually being shaded differently. Why? And then it restarts. Ha! That's fascinating. How did that end up like that? We can't look at the tessellation here because we're in GLES 2 mode. But this is probably just between a couple of tessellated points. Why would it give it the UV of that? Where's that pointing? That is crazy. Modprog, good morning. Hope you're having a good Friday. Oh, because even this, I don't know if you see it, but the angle of this changes, which is kind of neat. But it changes and it points to different space. Why is that? It's probably not necessary to figure that out, but okay, yeah, something else is going on. I mean, it's getting close. I like that little effect though. I think it'll be nice when it's done. Just have to figure that out. Why in the world would that be that? If I normalize that, would that do anything? Guessing that's the problem. It's radians. Yeah. Okay. Negative pi to pi, and that's what we thought it was when we started all of this, which is why this was mutable. Radians plus equals standard F32 const pi divided by equal to uh, good morning. How you doing? Stryhex. What's going on? And happy Friday. Expected a semicolon. What? No. Oh, this is supposed to be consts plural? I think we need to restart Vim. All right. There's something going on with Vim. Again. Oh, come on. I thought we had it that time. Border box. Is it UVs? Oh, Why don't we do it this way? Divided by, because here the angle from x-axis should be from negative pi to pi, I think. Oh, that needs to be a 1.0. Let's double check on that. Positive value is counted counterclockwise, whereas 0 is plus axis. Pi divided by 2 is y-axis. Return angle is between negative pi and pi. What theme do I use for Vim? Great question. We use Challenger Deep. And we have commands. Ah, oh, that's on. You're welcome. You're welcome. And if you were asking about uh, some of the other streamers, actually, I haven't seen Uraniwa on in a while. Hope they're doing well. Compiling actually takes a lot longer when I'm streaming. I think I need to adjust my streaming setup. All right, that's good. Oh, I still had Godot open. That actually chews up some CPU and makes it longer. All right, now we're actually interested in the log output. Oh, it's going to 2 plus 1 divided by 2. Because we want the value between 0 and 1. We'll restart that in just a minute. You have any weekend plans? I might try to go on a hike. Probably got to do some barbecue stuff. Playing Valheim. How do you like that? I've only seen it like in the periphery of my awareness. See, that did build. Good. I saw somebody playing a game. What was it yesterday? Oh, look at that. Was it still doing it? For whatever reason, this section here is different than the rest of it. To one point. Wait, what? Okay, so -3 should be closer to 0. Why is this not really? This is incredibly difficult today. Just having one heck of a time getting this set up right. So we have radians coming in, and let's say it's -3, right? It should not be negative at the other end. It should be a value between 0 and 1, unless, of course. Ah, shoot, you are absolutely right. Tamatutu, thank you, thank you. Yeah, that would do it. Wow, need to be able to give people points, imaginary internet points. It's still doing it? All right, let's check our values though. Let's say negative values here. Actually, that looks much better. The exchange rate on imaginary internet points sucks. It's more of an emotional thing. And 0 is close to half. That looks right to me. And then we get to a positive value, and this is close to 1. Good. But why? Why on the left side are these vertices kind of out of place? So these here are being shaded separate, like the UVs for these. Those aren't right. You know what? Let's change our shader for a minute. All right, black, that's fine. Mission is going to be uv dot x and a vector 3. Actually, that doesn't look that bad, but the gradient here is wrong. This is because of where it started, isn't it? Because we end up with there. So we tesslated that, right? And what, ah, let's get this set up right. So we have our rectangle. So just those verts on the left there, right? They are like this. And then I'm going to freehand the rest of this curve. Got a nice little curve going over there. Awesome. Beautiful art. All right, Halsey art's the best. All right, so then we have that. All right, and then we have more vertices in the corner just to make it pretty, right? And then it does the same sort of thing where you have this box and it progresses around. It's not actually like that, but it gives you an idea. The problem, though, is in this space, where we end up with a UV of, let's say, 1 here and 0 here. And so it progresses all the way around, right? We go from black all the way around to white, and then from white to black, right there. How do we fix that? Or why is it like that? Is it because of how we're adjusting adjusting it after the fact? I mean, we could just say our UV is from negative pi to pi. Let's just adjust that. Okay, what if we didn't do this? Just had the radians here. Use radians. All right, and then inside of Godot, we're going to change this so that instead of operating from 0 to 1, actually, I kind of want to see what that looks like afterwards. This is going to be that divided by pi. Yep, and we didn't restart yet, so it's still got the old values. Let's give it a restart. Oh, okay, get rid of you. That's a misspelling. Radans. All right, that's good. That built. Run it again. So now that we have it, the UV from negative pi to pi, I think it's still doing the same thing because this gradient here is too fast. And what should it be? I mean, how do we do that? I mean, maybe we could have two of them. I don't like that idea. Because we're always going to get to the point where the value flips back over immediately, right? Hadn't considered that before. So that's where it crosses over from 0 to 1. And then the rest of the track is going back from 1 to 0. But if we did this the same on each side, the max must be 0.5 and not 1. I hadn't considered that this jumps suddenly, right? And it's still going to do that even if we don't have that being converted between 0 and 1. 0 and 1 is nice though. And even if we bring it back to pi, of course, it's going to have this very sharp restart somewhere. I'm going to undo that. Okay, there's our parens. So when it's wrapped from 0 to 1, 0.5 is at equal distance. Are you saying that this should be 0.5 here? We'd still be going from 0 to that. So the rest of it would be going from 0 to 0.5 and then back down to 0 very quickly. Problem is this little strip right here, there's a whole transition again. Were you saying that, oh, hold on. If we took the absolute value of the radians, right, now it's between those two values. We no longer need to add 1 to it. So in this case, it's going to be 0 to pi, right? Actually, I don't like having the variable called radians not actually represent radians. So here we'll take the absolute value of radians. So it goes from 0 to 1. Does this just make the same problem happen twice though? Because then at two places we'll be going from 0 to 0.5. We actually need to go up and then down. So if we had values from like negative 3.14 dot dot to 3.14, right? So if we have that coming in, let's put this in a comment. What do we want out? Coming out, we want 1 dot dot 0 dot dot 1, right? So it's nice and smooth all the way around. So when it wraps from 0 to 1, 0.5 is the at equal distance. Because angles are circular, 0 equals 1, after you normalize it. So it's abrupt. You need to shift it to 0.5, so it shades from 0 to 0.5, then back from 0.5 to 1. Right, so are you saying that, and this is hard to communicate over this, I get this. So we have 0, right? Then we have a little grid here. This goes to 1 here, and then from 1 back to 0, right? Or are you saying we go from 1 to 0.5, which is basically the same thing. It's a transition and then back. Let's say this is A and this is B, or triple B. Well, that's a horrible B. because it seems like either one of these is going to be doing the same thing. That we have smooth transition around. B. Now, I actually want to take it all the way to 0 though, so we get the full gradient of the color. Yeah, or A, but that's not what I did. Okay. I think we have the same thing in mind now. And what does this give us again? Returns a positive, the signed angle between this vector and the x-axis. Positive value is counted counterclockwise, whereas 0 is plus x-axis. Basically, you need to center at 0.5, not scale to 0.5. Hmm. And 0.5 here is just some arbitrary value, right? We could be saying you need to scale at 0.25 or 0 or 3. Or is 0.5 some other value that I just don't understand? Not because I've normalized my range of value. I mean, this is giving me a value. I mean, this here is, well, technically it's 0 to pi to, oh, actually, yeah, because it goes along the top curve in this. What are the units? Is this going to be, and I'm just second guessing myself on everything. So it's 0, right? We have origin here, and this here will be 3.14, right? That'll be pi there. Um, right? That's correct. That's good. Now, when we come back around, does it start at negative pi and go to 0? U is in 0 to 1. Yes, yes. Currently, but I'm just trying to figure this out because here, this radians is value in this range, right? This is how the it's set up. Oh, shoot. Did not mean to do that. Man, because I thought that would be 0 starting there, and it would come around to 1, jump to 0, right, which is what we were seeing. Or is it 0 here? See, when I think about this, I usually think about it in terms of like 0 to pi and then to 2 pi, right? Right, 2 pi would be over here. But that doesn't seem to be the case. It's like 0 to pi, and then this is magical. It's funny, you learn all this forever ago, and then you have to go relearn it. Positive values are counterclockwise, where x is plus axis. Pi divided by 2 is y-axis. The return value is between negative pi and pi. Right, so half pi is positive x. Okay. You have the same jump in value where you come close to pi, then jump to negative pi. I don't follow. Yeah, basically it's going to happen twice, right? Which is what I think that's what you're saying is that transition is going to happen twice as we go around the circle. So if the values are between 0, 3.14, that, and if we wanted to take that into something like this, what would we do? We would just take the absolute value of that and divide by pi. So we take the absolute value of that, divide by pi, and Bob's your uncle. And then we go from 1 to 0 back to 1. Let's prop Godot, kill it, wait for it. Oh, and thank you for the follow. All right, so we have that. Good. Start it again. And thank you for spending the time on this with me. Oops, what do we got here? Okay, we're back to our gradient, and it's looking pretty good. Say 3 is close to 1. That's fine. Let's go back up. Yeah, those values look reasonable. Let's go back to our shader. Let's delete this value. That's a little different. Not quite what I had in mind, though. Or we just do this negative 1 to 1. Right, because then we should be able to do that. We can adjust for this here. So 2 pi. All right, let's not take their absolute value. We'll just go from negative 1 to 1. I think I see why you were saying 0.5 now, right? Because zero point 0.5 should be the midpoint. So if instead we did that, divided by tau, TAO, and we added zero point 0.5, okay, let's close this. Getting so close. Okay, that's close. It's morning. Gotta get the stretches in. Is it doing the same thing? Same thing as before, right? Oh, it is. I fell into the trap. So now, I guess I'm trying to do this in kind of a clever way. Let's do it this way. If, oh, radians is positive, because in this case, I want just radians. In this case, I want, actually, that zero point 0.5, it's finally starting to sink in. I think I'm finally understanding it. So in this case, if we're going from 0 over, then we could just leave it, or we divide it by pi. All right, but in this case, now we wanted to shift back, we wanted to come back around, but this needs to be that divided by that. Actually, it needs to be tau plus 0.5. So we're going to put that in the top range from 0.5 to 1. And we'll have negative. Now we're still going to have that gap. We're still going to have that thing. So no, we don't want to do the shift. We're going to end up with two blobs going around. Whoosh, which would look pretty. Not exactly what I wanted, but it'll work. Just because of the way that the shader works. Yeah. Now this one is going to be from negative 3.14 to 0. And if we take the absolute value of it, it's not exactly what I want because I just want it shifted. I don't want it flipped. So let's add. You think radiance at absolute value was right? But that gave us the effect where it glowed from one end to the other because we had 1 and then we had 0, right? Or 0 and then 1. And I would rather it um, go from, oh, I see what you're saying, because, yeah, I think you're right. Yeah, to make the max value 0. Um, because if we do it the way that I'm thinking here, this would end up going from 0 to 1, and then, yeah, it's not going to work. Because we'd just end up with 2 little spots that are messed up on the left, like this, right? The way I'm going, we're going to end up with 2 of these, 1 on each side, and that's not good. See this? Yeah, that's what we're trying to fix. So maybe I shouldn't be converting this at all. Because we have u and v, maybe we just need to provide a v. And that's the normalized vert. Hold on, let's just, then we have u and v that we can use. And then we adjust the shader so that it's actually going around. All right. Yeah, the thing is, I don't think what I want is possible doing it that way. Because the real goal would be to have it, kind of glowing except for this little spot here. And that one spot would move around, either right or left. I don't care, clockwise or counterclockwise. But that little spot there, gonna move around. Try to make it feel like a little projection that has some sort of fault in it. We do that. Okay, that built. Let's run it. All right. Yeah, that's kind of the same that we had before, right? Because it goes from from 0 all the way across. But now we want to change this so that our UV value is on or off based on the time. Let's go back to our shader. But I think this is going to work. Let's get chat back up on the screen. There we go. All right. So we have UV, right, which is our point around a circle, and we have time. Yeah, this is the old one. We need these. Now we need to be able to give it a, a value of how close this is to what the mix is between these, right? Is this more black? Is it more kind of gold? Power is going to be, let's say, out of time, this should just make it pulse. Oh, it's a vec3. Wait, no, it's not. This should be a float. Oh, I missed Vim in there. Yeah, that just makes it pulse, right? Good. Now, what you were saying before, because we have UV, right? And UV is of vec2. And what can we do that would take that information into account? Because that's each individual light, right? So in this case, the problem is how do you do this for each different pixel around the circle? So we need the angle from 0 to this UV, and then its distance from time to that. So what is our, I guess, angle here? And this is a normalized value, right? This UV, yeah, it was normalized. I don't see the Godot docs. Help, online docs. What I think this is going to be is the, as you said before, the dot product of the two vectors, the normalized vectors, right? What if we kept the UV as XY and did the conversion to radians inside the shader? The shader doesn't know the width of the shape. The shader only knows where the individual pixels are. So being able to convert it inside the shader, it doesn't work because we don't know where it is in relation to other points. That's a good question. Good question. All right, we want the shading language. Those are the types. We want the built-in functions. Okay. Radians, degrees, radians. Sine, cosine, arctangent. Mix, step, smooth step, distance, dot. Here we go. And if we take the dot product between them, you could calculate a vector that points from the center to the highlight, which rotates in time, and then in the shader calculate the angle between that clock and the current pixel, determine the color. Yeah, I was thinking of even moving the calculation into the shader. So we just give the points of this in yeah, I think we're thinking the same thing, because here, what we have here, the UV at this point represents um, the normalized, uh, I guess, clock face of this shape. Right? So it's basically 0 to 1 for X and Y that represent these points here. Yeah, unfortunately, we can't give it. I guess we could try to provide UV2 and then use both of those inside the shader. Because I think we also have available to us UV2. And if we wanted to be able to know what the maximum was, we could do that. Yeah, it wouldn't be constant. It would be faster along the well, would it? Because if we normalize this point here, the angle, that vector, it just shortens it. Then if we went around, oh, you're right. Because it's going to go slower in the middle here and faster on the edges. Yes, you are absolutely right there. Hmm. Is there a way to make it constant, though? We'd have to know the width and the height, and the distance to it. Or we have modes, right? We have top, right, bottom, and left, and it crawls across at a given speed. But then for a given UV coordinate, we'd need to know how far across to make it. And how, I guess, what the distance is. So we can use time to know the different distance. What if I map the chords of the rectangle to points on a circle and did the angle calculation in the shader? So that's currently what we have. UV is that. UV represents these points on a circle at the moment. Hold on a sec. I need to tend to something. Give me 2 minutes. If it always has a rectangular shape. Yeah, I think it's always going to be rectangular, right? Trouble is the rounded corners then. What do we do with that? All right, let's just display this for a moment. There's X, there's Y. Interesting that Y is not as bright. Was that not normalized properly? I thought this was supposed to be, is that only half pi? Huh. All right, let's try to split it into sections. And if we do that, do we go with providing an X and Y or just an X, like a racetrack again? All right. I think the information needs to have the 2 dimensions because the transition point from high to low will always be graded. Sorry, the wrapping got me. But if you have two, I have a helper. But if you have 2 dimensions, you can inject the extra information into that second dimension. True. All right, so let's see. If if time is going to be constant, right? So let's say here we have this in such a way that time is just, you know, we take the time as just the value of sine of time. Does that give us? So we want the sine of the cosine of that to get the height. Okay, so what are we going to provide here? We want the points to be able to glow in a very constant speed around a oblong rectangle, right? Just maybe it's twice as wide as it is tall. So what do computers like to eat? Microchips. Ta-da-ch. Sorry, my helper is distracting me. Um, so at this point, we would need to take into account time. Let's say kind of a constant way time goes across this. Hmm, how do we do that? Do we end up with from like x to like coming across here? Um, Oops, forgot. So if we had something like this, a little more boxy. All right, it would take twice as long to go across the top as it would the sides, right? And how do we communicate that to the shader? Saying that because the shader is not going to know, or is it? Can we provide this with a distance? So let's say we start up here at 0, 0. Does that make this 1, 1? Because if it does, right, doing this is fairly straightforward, going from 0 to 1 here. But then how do you say, you know, the shader goes from up and around like that? Because you'd have to determine, based on time, where you are in the shader. Right? Maybe divide time by 4, right? Or time mod 4. That'd be mod time 4.0 would give us the side. And then based on the side, we need to go from left to right. Right? But that would be dividing the dimensions equally, and would go faster across the top than the sides. So that won't work. We need to know what the dimensions are for this shape. Isn't what I did before, uh, sampling the rectangle path? Um, it it is, right? Because we have the points of the rectangle. And that's what the verts are. So we'll have like this point, this point. We have more points around the corners than we do on the edges. Because really this is, like rounded, etc. It doesn't have to be rounded though. We can always go from here to that corner is the same distance. That's 0 to 1. So if the distance from here to here is 1, then this would get like 75% of that, and this would get 25%, or a third. This would get a third, and this would get 2/3. So we could divide it up that way and pass it in. What else could we do? I don't know how we would calculate the corners because we don't know when a corner piece is actually in here. It's not on one of these lines, so we couldn't calculate it being on one of the lines. We could try. That'd be a little messy. Or is it kind of angular velocity? So are you talking about like for the shader? Because for the shader, um, you don't get to know anything except for your UV, which is the point. And from this data, we have to calculate whether or not the point is illuminated. Right? We have no information whether our neighbor is illuminated, etc. So we only get the time plus this. And based on time, oh, rotate the shader based on a variable velocity. Oh, interesting. I see what you're saying now. So, ooh. So as it's coming across the top, we adjust it. This would be interesting coming across the top. I'm going to take that into account. The speed coming from here to here, and then from here to here. Huh, that's an interesting idea. Because given a point in this, we'd have to tell. Oh, I see. Interesting. Hmm. I like that idea. Because our origin point could be in here, right? Or it could be up here. I kind of prefer just having it up here on the top left. Then calculating across and down, I think would be simpler if we were doing the racetrack version where the UV is actually from 0 to 1 and then from 1 back to 0. That I think would be fairly straightforward. Oh, except for the curves. The curves it wouldn't work on. Because, yeah, we'd have to figure out the... Because given any point, what is this thing's... What is that thing's UV, right? And it compared to, 1, 2, 3, this one. Yeah, I think if we took the distance, right? Because we know what the width and the height is here in this code. Let's say this is actually 2, 1, right? Then we could, from origin here, know that this point is most of the way over. And then we calculate its distance around this kind of Manhattan distance style. Like where are you on your path? That would work for the top, basically the first side and the second side. Okay, let's try that. There's origin. And I'm going for the double, um, the mirrored pairs. And we're just going to have one, we're just going to use X here. Same as before. We might be able to use Y though for the return trip. So maybe this here is, for the Y side, this would be like 0 and this would be 1. We could communicate that to the shader. Then I could transition. All right. So given a point, we do not need center anymore. We need kind of top left. Let origin equal to vector 2, or that's going to be self dot left and self dot bottom. No, top. Now this here is going to be a negative value. Okay, that's our origin point. Now we also need our width and height. Oh, you know what? This is a size, isn't it? That's backwards. Is that right? That's going to be a smaller value. This is plus. All right, that's size. What? Do we not have size? Euclid size 2D? Huh. I know it's in Lyon, but I don't know what the type alias is. All right, so now we have the vert. And if we're going from 0, 0 to over there, we need to calculate the distance or length, track length. This is that, and that's the same as, okay. So those are both positive values. Track length is equal to, or half the track. So if we were just going across the top right, it would be fairly simple. We would just go across and then down. Right? However, this would be negative y because of Godot. Now, if we were coming back though, we'd have a positive value here, and this would be like, let's say it's close to 2. Because this value is going to be the same as, let's say, that value, right? but we need to know which half of the track it's on. Because if it's on this half, we go one direction. If it's on this half, we go this direction. Because these values will always be adding up to the same thing. Thank you for the follow. Because if we can't get that information, then we're stuck with it just kind of going whoosh, kind of the way it was, but left to right instead of corner to corner, instead of the diagonal. And we don't want that. We want it to come back. So we could tell which side it's on. If it's on the bottom, just to, to tell whether or not it's beyond halfway. Say, okay, if you're beyond this line here, you're on the bottom. If you're to the left of this side here, you're on the left. Top right, bottom left. So we could figure that out. We need center again. Match. We're going to match a tuple. So we're going to say center.x. If center.x is less than vector.x and center.y less than vector.y. Okay, now we should have a truth table. What? What? You just found somebody's vimRC and he's bound tab, shift tab to normal mode to navigate tabs. Oh, wow. I don't use tabs. Oh, that's funny. That's a great idea though. True, true. Do this. True, false. False and false. True, 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 false, false, true, false, false. All right, so if, actually I want to flip this. Oh, it flipped this sign too. That's interesting. Watch this. Flip binary expression. It actually flips that. You're committing to nvim.lisp? COC has been auto-completing garbage into your buffers for the last month. Really? Oh, we actually saw that. Somebody figured that out. It had to do with in your vim config directory, there is a temp file that has some garbage in it, and it has to do something with vim state, like session state. And if you clear that, that garbage goes away. Oh, we call it vert. It's true. I saw it on the internet. All right. So if the vert is in the top left quadrant, oh, that's an interesting way. Um, yeah, it's never happened to me though. What in the world? Oh, those are like snippets and test stuff. There's a lot in here that I'm not using. Well, but they said it was kind of top level or just inside something. Um, but if you search for some of that garbage in there, you'll probably find it. So it's easier to split this up into quadrants like Q1, 2, 3, and 4. What if we just did that? What if it was 1, 2? So this would be this would be area 1, true, false. Yeah, this would be 2, 3, and then 4. And that doesn't really help us, does it? Unless we're going from here to there. And that, oh, that might actually be cleaner because of the curves. Like curves, I don't know what the curves are going to do. Um, I like the other way better. I don't know if we're going to keep the quadrants like that. I don't really want to do quadrants like that. I'd rather split it up in an X, but the curves fit much more nicely in the quadrants. So it's easier to tell. The symmetry wasn't there. It was off by a space. I had to fix it. And we could calculate the distance around the quadrant, and that would work, wouldn't it? Because the distance is going to be half the width, half the height. Why don't we just return the UV here? In this case, U, being the top left quadrant, I'm going to take the negative value for the vert, the vert's Y, plus vert's at X. So that'll be in the first quadrant. And if that's 0 to 1, we could deal with the quadrant information in the shader. That would be okay. What's this one going to be? This is quadrant 2. So it's going to be, yeah, the X. Is this the same thing? It feels like the same thing. Plus the height. They're all the same, except for the quadrant number. Okay. Hmm. All right, so we have that. We return there. We do not need distance. Good. Unused variable origin, quadrant length. Oh, our distance here is supposed to be from 0 to 1. We do not need origin. We're using center. All right, let's click Godot. Run it just after it builds. All right, so here we're gonna get back into this, and my end time is actually counting near because coffee is being made. All right, so here we have this. We can tell which quadrant we're in based on Y. If we divide that by 4, 4.0, should see the quadrant numbers represented as glow strength. Seems about right. You see that it blends from one side to the other because the shader will sample. Because that vertex over there is probably close to 1. This one over here is, well, this is 1, this is 2. 1, 2, 3, 4. Hmm. That looks strange. Why is this one, why is that one the brightest? That's surprising. Front view, no, front view. I mean, these two kind of look similar. That means this is wrong. Center. That should be the set that we verified this was working before. So bottom's -10 and the top is, let's say, -7. Center should be halfway between those. So -10 minus -7, we what 3, and so it's -3 divided by 2, -1.5. Seems right. So the vertice, this should be correct orientation. The match is false? So in this case, left, left. Quadrant 1 here, as if vert x, this should be above. Ah, I see, that's down. So here, if the vert x is less than the center x, okay, that's on the left side. And now the vertex y, if it's greater than the center, then that's up. Okay, that should fix that. So true, true for quadrant 1. Quadrant 2, x, oh, this is backwards, isn't it? This is false. True. Now on the left, we have true, false. This is 3. And false, false, we have 4. So true, true, false, 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 true, true, false. I found this to be a really, really great tool. Just being able to draw the color, the values onto a mesh to see what the values are. I could write a test, but I just don't feel like it right now. And I want to understand it. I feel like once I understand something, then I'm more able to write tests for it. You'll typically see me go through that pattern where I do something for a little bit and still false invert 3 and 4. Oh, thank you. Let's see. So for 3 and 4, if we're in oh, 3. Ah, yes. Because it's going clockwise. It's not 1, 2, 3, 4. So 3 in this case here. Yeah, it's not less than half. Oops, undo that. Thank you, Timututu. Thank you. Okay, we're gonna let that build. All right, kill that, run it again. Does this look correct? Yes, that looks correct. Yay. Okay. You know what? I should probably call it there. And then we do this start of tomorrow. But that I think is going to work because we should be able to take those values then and have an if based on the quadrant and the time and how far it's moved. That should work. I'm gonna prep a raid. We're gonna raid today. Oh, there's a lot of people streaming right now. What do we got? Classy Cat, adding color to Tokai. Oh, that's cool. This is a source code analyzer. If you're not familiar with that, tells you how many rust, lines, etc., code comments, blanks, etc. That's what they're doing. Game of life in Rust. Oh, Jummit, making a dialogue tree plugin for the Godot engine. Let's go with, I don't think we've rated this person. We try to mix it up, right? Although, let's go with channel codes. I don't think we've rated them either. Maybe once before. Oh, thank you for the help today. That was incredibly helpful. Thank you, thank you, thank you. Um, I would have struggled for a long time on that. Now I feel like I gotta go like hop back into like Khan Academy and relearn a whole bunch of stuff. So thank you, Zenocron. I hope you find that little bit of cache in your config directory. If I remember who it was that was having the same problem. Oh, it was Bear Duda. Bear Duda had the same problem. You could probably reach out to Bear Duda if you have more information, if you need more info on that. So, till next time, y'all. Bye bye. I'm reading a book about gravity. It's impossible to put down.